Okay, so let's get started, y'all. So again, these are our 4 properties of logarithm. Whoops. So these are our 4 properties of logarithm, and we use these to expand our equations. So let's go to number 3. Log base b of x to the third times y divided by z squared. So times multiplication inside of log is addition of logs. Division of logs is division inside the logarithmic function is subtraction of logs. All right, so let's do that. So this equals log base b of x cubed. X cubed times y minus log base b of z squared. Okay, now I have multiplication, and I can write that as addition. Now I can smell this one again. Can you smell this?
Oh, yeah.
It smells like the projector, this new screen. It smells like permanent marker, kind of. We just got the screen. Let's not push our luck here. Okay. So I did addition, I did multiplication and division. Now let's do the power. Right? I can bring the power out in front. So everybody try to write that down. Final answer. How do I get what?
Like, how do you just change it from the multiplication to addition? And you just get that?
Because it's the rules.
How do you know that that's the rule? Which rule that is?
So here, from here to here, I have division, right? So division changes to subtraction.
Oh, it's the change of base.
No, it's not change of base. It's the quotient rule. I'm dividing inside of log, which leads to subtraction of logs. So that's the first step. Then I say, okay, let's look here. This is multiplication inside log, which is addition of logs, right? Okay, so now I'm not multiplying or dividing inside of the log. I just have powers, so I can bring those powers out in front. That's what I did. So I looked at multiplication and division first, and then I looked at the exponents. Well, this one's a little bit different. Number 4, ln of the square root of e times x. Here, the exponent is on both things inside, right? So here, what's the square root as an exponent? 1/2. Good. So I can bring that 1/2 out in front. So that's the exponential property of log, the power rule. And now inside of log, I have multiplication. So multiplication inside of the log function goes to addition of logs. Remember, make sure you have those parentheses because that square root is on e and x. Can you guys see back there? There's a lot of squinting going on today. ln, which is natural log, right? Okay, what is ln of e? What do you mean cancel? It's 1, right, Josh? So that's like e to the what power equals e, right? If we went back to the definition, e to the what power equals e. Well, it has to be 1, right? So this equals 1/2 times 1 plus ln of x. Because that equals 1. Okay, good. All right. I feel like you guys need to move up or something today.
No, I just don't understand.
Okay, what don't you understand?
The whole thing. It's so confusing. I don't know. I'm just following along and, yeah.
Okay, so I'm going off of these rules. That's the only thing I'm looking at for this. I'm trying to use these properties to expand. So I'm using these 4 things. I'm saying, okay, let me look at this one. Okay, I have ln of the square root of e to the x. The square root is the 1/2 power, so I can do the power rule right here. Bring that power out in front. So I have 1/2 e ln of e times x. Now I have e times x. That's multiplication inside of log. Then I can put log of one thing plus log of the other thing when it's multiplication inside.
Oh, yeah.
So that's what I did there. And then we remembered from 4.2, ln of e is 1. That's it.
Okay.
So I'm using these properties over and over and over to expand.
Okay.
I'm not solving anything. I'm just expanding it using these properties because these properties are really essential in order to solve this stuff.
Back to book 3, why wouldn't you have used change of base?
So the change of base is if I have log base 10 of m divided by log base 10 of b.
Okay, so
Here I'm dividing inside of log and I'm not dividing logs, right? That's everybody's main mistake. Here I'm dividing logs, here I'm dividing inside of log. Very different. All right, so let's go to number 5. All right, I want you guys to try this on your own. If you need to write down step by step, then do it. If you can go straight to the answer, go straight to the answer. I have multiplication in the numerator, and I have powers on each of those things. I have division, and then I have a power. So I would write down multiplication and division first, using the rules up above, and then I would do the powers. So here I have multiplication in the numerator. That leads to addition of logs. And then I'm dividing. I have something in the numerator. Dividing inside of logs is subtraction of logs. So that's what I did with that. I could have written it out in 2 steps like I did with number 3, but I don't want to waste ink. Like this. Okay, so now I took care of multiplication and division, right? Okay, so now let me do the exponent. If I have something inside of log to a power, I can bring that power out in front of log. So now that's what I'm going to do. So this equals 4, because that's my power, log base b of x plus 1/2 log base b of x squared plus 3 minus 3, right? That's my exponent. I'm bringing my exponent out in front. The exponent on the inside of log, you can bring out in front of log. To me, that's the most important property of log because in order to solve an equation where the variable is in the exponent, you're going to use this. You have to know this one. That's like what the next section is, 4.4, solving. Did I get it right? Okay, so I want you guys to try number 6. Sorry, getting glasses. He doesn't need glasses, huh? I'm going to write down the final answer. So try it on your own and then check your work. So is this clear? Morgan, what's your question?
Oh, I just didn't split up the 100 and the x together.
Okay. And make sure these are all subtraction, right? You could do subtraction and then plus and distribute it in, but these should all be subtraction, whether you have the negative out in front.
You subtract them all. You don't do plus after that. I don't remember trying to calculate. Oh, that's just a question. So it's.
You could do it like this.
Okay.
That's fine.
Yeah, that's what I remember doing. I just have a 3 on the 2 or
A 3 on where?
a b.
Oh yeah, these are all log base B. I feel like everybody's mind is blown right now.
I just don't understand how in number 3 you went from, it's the same type of problem pretty much. It started off in the first parenthesis as x cubed, and you said log b plus x cubed, and then in the next problem you changed it from log b times x to the 4th, and now in this problem it's
Times x to the 4th. What are you looking at?
I'm looking at the other problems.
So what don't you get?
I don't get a lot of them. So oh wait, is this because you
So this is good, you're just not finished. I just went to the answer. I wanted you guys to try it on your own. So after you do all of those steps, I've done this about 1,000 times. If you want to do step by step, do step by step like we did in 3 and 5. But then at the end, after you do the multiplication inside of logs equals addition of logs. Multiplication inside of logs equals addition. Okay, division equals subtraction of logs. Division. I could have written it as a whole page of steps, right? And then bring the exponent out in front. That should be like your last step. Once you split up the multiplication and division inside of log, then do the exponent.
Wait, I got a question. I thought you said, wait, would this b equal a 10, or was that just for something else? Because
So if there is not a b here, right, this is b. If there is not a b, not a number, then it's an implied 10. But here there's a b, I don't know what b is.
alright.
So I see you're thinking like maybe it would equal 2. Is that what you're thinking? Yeah. But it equals, our base is b. So we don't know what that is. So I thought you guys were going to be working on this one on your own, do the 10 steps like we did in these other ones, and then look at it. It's not, if you haven't done it a bunch, jumping just to the answer can be tricky. So write down all the steps on your own.
I did. I just left the 10, I mean the 100 and the x together.
Yeah, that's what some other people said.
Yeah,
Did
but
you get that?
What's your
Did somebody else in the back, you guys?
I was going to ask you.
What?
Yeah, I'll ask you after class.
Is it something about this question?
That's about like the whole second section.
whole what?
The whole section is very confused, that's all. So that's what I'm going to ask you after class.
Okay. So the first place to start is to know these rules. So we just went from the left-hand side to the right-hand side. Now on the next page, we're going from the right-hand side to the left-hand side. So let's do that. So again, I'm referencing these rules. These are the main ideas. So now I'm writing the following as a single logarithm. So I have something like the right-hand side. Now I need to move to the left-hand side. Okay, so I have 3 times log base b of z plus 4 log base b of x. Okay, if I have a number in front of the log, I can put that as an exponent inside of log. Okay, so that's what I'm doing. So log base b of z to the third plus log base b of x to the fourth. Right? That's the power rule, the exponent rule. Now I have addition of logs, and these have to be the same bases. If this is base 3 and this is base 5, I can't combine them. But these are both base b, right? I have addition of logs, so I can change that to multiplication. Whatever you have inside of log, you multiply now. So this is log base b of z to the third times x to the fourth. So now I'm just going backwards. I'm going from the right-hand side to the left-hand side. All right, you guys try number 8. So now I'm looking at the number in front and trying to do the power rule first, and then I'm doing multiplication and addition, or addition and subtraction. Okay, so let me do the exponent first. What's that 1/2 power again? That's a square root, so I have log square root x plus 2 minus log x. Okay, now I have subtraction of logs. Same base. What's my base here? 10. Same base. So I have log base something. So I'm subtracting between those same bases. That means I can divide inside of the logarithm function. So that equals log of the square root of x plus 2 over x. So notice I'm trying to get a little more complicated for each question. As you can see, 9 and 10 can get a little hairy, right? So the first 2 examples are supposed to be more straightforward and easier. Now we're adding a little bit more to it, right? So again, I like to use the power rule first and then do multiplication and division, or addition and subtraction. Okay, so here I have a 3 in front. The 3 in front goes to a power. Okay, log base 3, log base 3, log base 3. Okay, so they're all the same base. So then I can change addition and subtraction to multiplication and division. Okay, so I have log base 3 of z to the third. What's that 1/2 power again? Square root. So I'm changing all the numbers in front of log to exponents. Okay, now I have subtraction of logs. Subtraction of logs goes to division inside of log. So here I'm going step by step by step, writing out all of the details, right? I'm going to ask you guys to do number 10 on your own, and I'm just going to go to the answer. So this is not the final answer because I still have addition of logs. When I'm trying to write it as a single logarithm, so I'm trying to only write log 1 time. Here I have addition of logs with the same base. Addition of logs leads to multiplication inside the log function. How do I multiply these fractions? So this becomes times 3y to the third, right? Times y to the third. When I multiply fractions, that goes in the numerator. Okay, so now, like I said, I want you guys to try number 10 on your own, and I'm going to write out my final answer. So if you wrote it out in a bunch of steps, that's fine. I just wrote out my final answer. You guys should try to do it on your own. Okay, did you guys all get it? Okay, so now somehow number 2 and number 2 down here. We need to use our calculator to evaluate this. Okay, which of the 4 rules can we use for these problems? Which of the 4 rules can we use for this? Change of base. That's the only thing that's going to work. I don't have multiplication, division inside of logs. I don't have something to a power inside of the log. I have to use change of base. The thing is when you do log in your calculator, it assumes that the base is 10. If you forget, look, right above log is a little 10. Right above natural log is E. So that should help you remember, make the connection in case you forget it, right? So if I type in log into my calculator, it assumes I'm doing base 10 because that's what it is. Okay, so basically I need to know the change of base formula, which is this. Log base b of m equals log of m over log of b. So I'm just going to write that down. So this equals log of 7 over log of 8. And then I can put that into my calculator. Log of 7 divided by log of 8. Right, make sure you have parentheses right there when I did log. Make sure you have parentheses at the end of it. So this equals 0.93578. I mean, I think log of 7 over log of 8 is the best answer, but if you want to put it in your calculator.
Okay, yeah. So we can't leave it log of 7 over 8.
Well, it says use your calculator to evaluate. So I would just make sure I followed the directions. Like if it's homework and it says round to the 3rd decimal place, make sure you do, right? Okay, what about log base 2 of 8? I can do that using the definition of log without my calculator, right? If I set this equal to x, I think there is a question like this on your extra credit, right? What equation is equivalent to this, right? There's one on the extra credit, maybe. Maybe I made that up. Okay, so here it just says what is the equation that's equivalent. So you set it equal to x and you do the definition. 2 to the x equals 8. X equals 3. So here we could do that from the definition, or we could do change of base. Log of 8 over log of 2, if you put it in your calculator, still equals 3, right? No matter how you do it, it should equal the same thing, right? Alrighty, so that is 4.3. So let's get to 4.5.